Hi everybody, as you heard, my name is Mark Dalgleish. I'm here from Melbourne, Australia. And I'm here today to talk to you about the end of global CSS, which is a lofty title. But hopefully by the end of this you'll understand why. A lot of things have been changing in the CSS space. A lot of people trying new things, and it's definitely something I've been a part of. And I'm really excited today to share some of the work myself and a few others have been doing to really try and rethink how we build our applications with CSS. So to put all of this in its proper context, I think I first need to take you back to the beginning, really to the beginning of my career, essentially. For me, personally, it all began with this book. Now, this book is not a classic. It's just a random HTML book I picked up in '99. I wasn't a programmer. I wasn't dreaming of becoming a programmer. I just loved the web, and I wanted to be part of it somehow, and this, for me, was a natural place to start. Now, it has a chapter in there, chapter 13, which is all about CSS. Now, at the time in '99, CSS wasn't quite ready for prime time, and that's what this summary says. But everyone knew that CSS was really going to change the way we think about styling our websites. It's already been covered this morning, actually, that CSS Zen Garden is something that was really what convinced me that CSS was something you could really fall in love with. CSS Zen Garden, the whole concept, as you already heard today, was about taking a document and completely restyling it just by swapping out the CSS. So just by changing the CSS, you could go to a completely different look and feel. And this really, at the time, proved out a completely opposite approach to what we were doing with things like table-based layouts and font tags, where the design was tightly coupled to the markup. So CSS Zen Garden presented a really great way forward for us as a web community. But as we move forward in time, we get a bit of a clash between the techniques presented in CSS Zen Garden and how you build a complex web application. While one is just a basic document, basically a glorified version of what we were doing in things like Word, web apps are a very different environment entirely. And the problem with that is that when you're restyling a document, the global scope of CSS is a good thing. You want to be able to restyle any element on the page very quickly, very easily. But that comes with a maintenance cost when you get into the world of big, complex applications with lots of nested components. Over the years in the CSS community, we've come up with a lot of techniques to try and tame the problems inherent with CSS at scale. We've got things like OOCSS, which arguably kicked this off. Other techniques like SMAX, BEM, Suit, and now, controversially in the React community, inline styles is actually a feasible solution to this problem. But arguably the most popular solution out in the wild is BEM, Block Element Modifier. And ultimately, it's just a naming convention. It's a way of restricting yourself in the way that you use your CSS so that you can make this technology scale. And you can scale it over a long period of time and have a code base that's actually able to be maintained, able to be refactored, which for legacy CSS code bases was basically impossible. When you apply BEM to your markup, you get something that looks like this. It does get quite a bit noisy, so obviously there was a bit of a cost in terms of the pure aesthetics of working with BEM. But for those of us that kind of got over that initial distaste of the markup, we ended up with something that was definitely a big step ahead of where we were with CSS in the past. The challenge here, though, is that CSS at scale, when you're using something like BEM, feels completely different to what you were doing in the world of CSS Zen Garden. The techniques you had to adopt were completely different, and there was definitely a learning curve. People who were good at CSS were not necessarily good at CSS at scale, and that was a real problem, particularly when you're working in a team environment. But this problem of scaling interfaces is not unique to CSS, of course. This question has been asked everywhere. And in the JavaScript community in particular, we've now basically arrived in what I call the age of components. If you look at the landscape at the moment and what people are using to build rich single-page applications, you've got, of course, web components landing as a standard part of the web platform. You've got Polymer polyfilling that so you can try to use that today. Angular is all about directives, and directives are about basically turning HTML into a DSL powered by components. But the one that I've been focusing on lately, it's been getting a lot of traction, is React. For me, the big reason I've picked React is I can render it on the server, so I get all the benefit of components without sacrificing progressive enhancement, which I think is very, very important. But components are nothing new. Components were not invented on the web. But even in the earliest days of the web, we had a basic set of components. You had things like select box with options in it, HTML5, date input. These things came with a lot of inbuilt behavior you just got for free. You just drop a simple tag in your markup, and all of this rich interactivity is now provided to you. And the interface is very, very simple. But the important thing to note here for the purposes of this talk is that CSS and images are private to a component. At no point do you have to worry about the styling or the images that a browser might need to render these things. They're completely abstracted away from you. And that, of course, came to a screeching halt the second you wanted to use a third-party component. So taking the canonical example of the jQuery UI date picker, just having a date picker, you've got over a dozen files, images, CSS, JavaScript, and it's your job to integrate this into your project, which was not necessarily the simplest of tasks. Certainly doable, but a lot more work than should be necessary. And our tools reflected this model for the longest time. You look at a build tool like Gulp, for example, and the standard way we would wire up our Gulp files would look something like this. You might have a task for your JavaScript that runs it through something like Browserify, maybe Uglify. You've got your CSS task, which might run it through Sass or Less or PostCSS. You've got your images task as well, and so on. And you were definitely sort of encouraged to separate everything by file type, and everything was in these silos. And this, of course, continued into tools like Sass, where ultimately Sass only cares about your CSS. So what that ends up causing is something like this, an index.scss, for example, where essentially it's just a wall of imports, because Sass has to know the full tree of styles in your app, but Sass has to start somewhere, and this is your entry point. But what do we do in the component age? Like, is there a way that we can rethink our tooling? And luckily for us, there's a really great example in the form of Webpack. Webpack is basically the default choice in the React community, and for really good reason. Because Webpack encourages us to think in terms of a single dependency tree across all of our asset types. So rather than the standard folder structure in your project where you might have JavaScript over here, CSS, images, and fonts in a different place, you're much more likely to structure your app like this, where you've got a components directory, maybe nested levels of components directories as well. And inside each of those, we have a folder for each component. That component has the JavaScript, the CSS, and any images it needs to render. And Webpack gives us a really great way to manage this. Because if you look at here, we've got a basic React component. The very first line, we're actually requiring a CSS file. So we're making it very explicit that this component depends on some CSS in order to render correctly. Whereas previously, that dependency between the markup and the CSS was basically in your head and scattered throughout your entire project. The great thing about Webpack is it can traverse these links even into your CSS. So Webpack follows the lead into that CSS file, and it can see that you've got a background image here of an icon.svg. And Webpack knows that it now needs to include that image in your final output. So here we have one build tool traversing multiple asset types. And you configure that with loaders. So you've got things like style loader, CSS loader, PostCSS, Less, Sass, URL. And there's a whole bunch more. And this is the way you teach Webpack about how to understand these different file types. You configure it like this. You don't have to understand this to any large degree right now, but the point is that you tell Webpack, if you see a CSS file, I want you to run it through this chain of loaders, go through PostCSS, CSS style, and so on. But what's great is that when you use these components, you maintain the simple interface. You just import a component and render it if you're building a React app. And all of the internals of the different asset types are abstracted from you. So how does BEM fit into this world of components? Well, luckily, a block in BEM is really the same abstraction as a component in something like React. It's dealing with the exact same problem in basically the same way. So this leads to a very simple rule of thumb, which is that you should never use a block in BEM outside a component of the same name. So that looks something like this. Again, if we revisit this folder structure, we've got our component directory with the JavaScript, the CSS, and the image. if you look inside that CSS file, it's called myComponent.css, and inside you'll notice every single selector starts with myComponent. We're essentially emulating local scope here. The file only affects the JavaScript in the same file, in the same folder. So to visualize that, what we've got is for every CSS file in this project, we've got a matching JavaScript file. That forms a natural component boundary, and the great thing about components, of course, is that they compose really nicely into a tree structure, forming the basis of your whole UI. So now we've got a way of scaling our CSS really, really nicely. Now, this is where, personally, I thought I was going to end with this technique for quite a long time. I wrote about it in a blog post called Block Element Modifying Your JavaScript Components, and this was something that I thought was going to do us well for a long time, work really, really well. But luckily, in the meantime, some really interesting developments were happening in the Webpack space. Webpack landed in its CSS loader an experimental feature called local scope. And it basically looks something like this. Whereas in the previous example, I just required a CSS file, and it was a pure side effect. It was just telling Webpack, include the CSS file. What you would do instead is you would actually import something from that style sheet into the scope of your JavaScript. So now you're importing styles from the style sheet. Now you might look at that as I did and wonder, what exactly is going on here? Like, what does this styles thing we've imported from a style sheet evaluate to? So to answer that, first let's look at the CSS. This is what you would see in the matching CSS file. This was a new syntax, custom syntax introduced into Webpack. You'd put :local and wrap it around the selector. So here we've got a local .header and a .footer. So what that means now is that if you go over to your React component in this case, we have access to styles.header and styles.footer, and these are just class strings that we're putting into our template. So now we're being even more explicit in the link between this JavaScript file requiring CSS and then what classes it actually wants to use from that CSS file. I'm sure you can imagine this is going to scale even better than what we were looking at before. So to understand what happens as part of the build process, if you look at that simple CSS file with a local.header and a local.footer, once it's come out the other end of Webpack, what you end up with is a hashed globally unique class name. So what happens when you import it is that you get an object that maps from the name you gave it, .header, to the global hash, which I'm not going to try to pronounce, of course. The amazing thing here is that we have no more naming collisions. You're free to have a dozen .headers in your app, and .root and .footer, .title, .logo. You can just call them basic classes like the good old days. You don't have to worry too much. And if you, for whatever reason, particularly in development, you might want to give your classes nicer names than just hashes, you have full control over it. So you can configure the Webpack loader to say that you want the identifier to be the name of the file, 2 underscores, and the name of the local. So in this case, what's happening is we're basically having Webpack write our BEM classes for us. We don't have to do it by hand anymore. Now, I work at a company in Australia called Seek, which is basically the #1 job site there. It's a household name. And a new project we were working on was leveraging these techniques. We were doing it in the BEM style mapping to classes. And as soon as we saw this local scope, we really couldn't help ourselves but port our entire app across to local scope. It was a natural fit. It was doing exactly what we were already doing in our application. So what that resulted in is any CSS file in our application, you would open it up and you would see this, a wall of local, 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 every single line, with very few exceptions. And that led to a very interesting question, which was, what if locally scoped CSS was the default? Why do we have to opt in every single selector into this? When really, when you look at any other sane module system, local scoping is the default and global is the exception. You should have to say, I want a global selector, not I want everything to be local specifically every time. What if we could write this instead? We opened up a new tab in our editor and we just wrote what we wished we could write. And ultimately, all that was deleting all of the locals. Now, when we came to what you see on that last line there, one of the very few exceptions where we needed a global class because of the way transition group works in React, we needed access to a global class. So we flipped the model around. We said if we say :global, we want that class to be global, but everything else is local. Now, we were able to achieve this quite easily with PostCSS, which Lachlan just covered in great detail, so obviously I don't have to go into too much detail here. But PostCSS is a really great tool for allowing you to do this sort of work, where you want to have your own custom transformations on the CSS. So as a result, on the train ride home from work that day, the same day I asked the question, it didn't take long to hack together an open source project called PostCSS Local Scope. And ultimately, all it did was it turned .class into :local.class, and it turned :global.class into .class, because that doesn't need to be hashed. I was very excited about where this was going. I wrote a blog post called The End of Global CSS, just like this talk, and to my surprise, it picked up a lot of traction, got a lot of views. People were really excited about what we were doing with CSS in our application. Arguably, the most important person to get excited about it was Tobias Koppers, the creator of Webpack. He reached out to me and he said, I hope it's okay if I integrate your PostCSS local scope module into the CSS loader. And of course, the obvious answer to that is yes. So we started talking about doing exactly this. Very shortly after this, CSS Loader landed a new feature, another experimental feature called module mode. So you just added $module to the end of your loader config, and this became part of the way it worked. You didn't need to use this PostCSS plugin with a PostCSS pipeline. It was all internal to the CSS Loader, and it all just worked for you out of the box. As part of my blog post, one of the things I talked about as a potential future was I said we could start generating shared classes between components automatically, treating style reuse as an optimization at compile time. What I meant by that was, if you look at what's happening when you import the styles object, you've got an object that says styles.foo maps to this global class, in this case a BEM style class. But when you use that in a template, there's really no reason that class could actually be a one-to-many mapping. When you say styles.foo, why does it have to be one class? It could be 3 or 4 or 100 for all you know. You actually don't care. And that creates a really interesting way for us to allow people to change their markup without having, change their CSS, without having to change the markup necessarily. This feature then very quickly landed in Webpack again under the name of composition after much bike shedding. And it looks something like this. So when you write a selector like .foo, inside of that you can say composes heading from typography and it composes box from layout. And what that means now is that this class is actually made out of 3 classes. If you drill down further, your typography CSS has a .heading class. Again, it's just locally scoped. And layout CSS has a .box. These, in the end up being globally unique hashes, but in day-to-day development, you don't have to worry about the names. So again, to really make this clear, when you import the styles from this style sheet, styles.foo is actually 3 classes from 3 different files, and you don't have to do all that work of putting all of these classes into your HTML. It's just kind of done for you. Now, I was really excited about what we were doing here, but my big fear was that this was, at the time, really just a feature embedded within Webpack. Not everyone uses Webpack. Tools come and go, but the ideas we had here, I thought, could really have a big impact on the future of CSS. So I reached out to Tobias Koppers and I said, have you thought about writing a standard for CSS modules that others could implement? I was particularly interested in where this could take the CSS community in the future when you look at something like NPM and what's happened to the JavaScript community there, because everyone agreed on a module system. I'm hoping that we can get there with CSS, and this is really the first step. We need to agree on a module system. So the next step, of course, was a new repository, a new organization on GitHub called CSS Modules. The initial commit you can see here, which was a big README describing what a CSS module is. And this started to get a lot more visibility from people now that it had a name. The missing thing, of course, was a logo, which I threw together first as a joke, but it kind of stuck. And it's now available in Webpack's official CSS loader as no longer marked as experimental. It's CSS modules mode. And everyone who's using Webpack today with CSS Loader already has the ability to plug CSS modules into their pipeline today, which is really exciting. One of the big contributions I made was creating the CSS modules Webpack demo. This runs through all the different features and tells you how they work, and you get to get a sense of what it looks like in a somewhat more realistic application. Now, an obvious question that might come up here is, do we have a hard dependency on React here? And the answer here, luckily, is no. Of course, we've seen it working with React, but it really works with any JavaScript framework. You've got, it works in Mercury, which is very similar to React. We've got examples in Angular, Angular 2 as well, Backbone, and we've seen examples in just vanilla JS, writing inner HTML or creating DOM nodes on the fly. Because as long as you can import styles into a JavaScript context, you can use CSS modules. The next obvious question from there is, does that mean CSS modules has a JavaScript dependency? I said I was a big fan of progressive enhancement. How does it work if we need JavaScript to be able to understand our styles? And luckily the answer to this as well is no, there is no JavaScript runtime dependency, only at build time. As an example of one way of many that you could solve this problem, I created a project called Static Site Generator Webpack plugin, and it basically lets you run JavaScript at build time to output a set of static HTML files, but you get all the benefits of Webpack, including CSS modules. So if you look at the source code for the Webpack demo that I showed you earlier, it actually has no JavaScript running in the browser. It's a pure static bundle of HTML and CSS, no JavaScript. And if you view source, you'll see that you basically have a bunch of BEM-style classes that are very similar to what you would have written by hand. But at development time, it's all locally scoped CSS, no manual BEM written out. It's all done for you at build time. Now, the future, of course, is going to require a lot more work because while we have a dependency on JavaScript at the moment, we're really interested in solving the problem of taking CSS modules to the broader web community. You know, how does this fit in with things like Rails, for example? What's the answer there? We've got a bunch of ideas. We're going to start a bunch of experiments. And by we, of course, I mean the CSS modules team. So we've attracted a lot of interest, some really smart people helping us out with this, including Glenn Madden, who's also here today as a complete coincidence, I swear. Yeah, I think the future looks really bright for CSS, even if it's not necessarily CSS modules, but what we're kicking off here I think is really, really important. So we've got it in Webpack today, but most importantly, I think we've proved that we can spread it beyond a single tool. We've also got it working in Browserify, JSPM, and again, if you feel like your build tool or your environment is missing from this list, by all means, please help us out and try to spread CSS modules beyond where it is today. I think a fair response to this for a lot of people would be that this looks complicated. You know, we're making CSS feel a lot more heavy and tool-driven. But there's a really important point here I want to hone in on. This model here of a component with everything localized is actually a much simpler model to work with. And I think it's much easier for beginners, importantly. All of these CSS methodologies come with a very steep learning curve for people who are new, and I think that this is actually a nicer starting point for people. Because each one of these components is a miniature CSS Zen garden. Everything's nice and simple within that boundary, and you're basically back in the simple days of the early web where it was just basic pages, and that scales really, really nicely. The main point I want to stress is that I think we need to have smarter tools, not stricter methodologies. These methodologies mean that onboarding people and upskilling people in CSS is a lot harder than it should be. And if we get the smarts into the tools, I think we can have a much better environment for beginners, as well as solving the problem of scaling CSS. So together, I think with things like CSS and thinking more about scoping things, together we can make big CSS feel like small CSS. And that's what CSS modules is really all about. That's it for me. Thank you so much for having me.
Hi, just want to ask, how does debugging work here?
Debugging, yeah. So for me, the fact that I can name my classes based on the file name and the local name is how we debug in our application. So what that means is that in development mode, when you open the DevTools, you can very quickly get a sense of where in your application, in which file these selectors are coming from. But the cool thing is that because it's completely configurable in your Webpack config, we actually have minified class names in production. We have 5-character hashes. So we found that that's actually plenty for us to debug. We haven't had any need for anything like source maps or anything like that.
Just being curious, what happens when you have some global styles you absolutely have to include, like Bootstrap or Foundation CSS?
Yeah, so I guess there's a couple answers to this question. Like in our application, we started with the classic like Eric Mayer CSS reset. That of course has to be global. It's styling tags. So what we do is we wrap that in colon global and just say all of these styles have to be in the global scope. The other, I guess there's a broader answer or more of a discussion around something like Bootstrap, where I think there's probably one of the things I really want to focus on after this conference is looking at how we can better support something like Bootstrap. So to use your Bootstrap classes, you would have to explicitly import them. You can't just assume they're in the global scope. But I'd like to argue that if we introduce a module system to CSS, I think that will need to usher in a new era of frameworks that are built, understanding that there's a module system. In the same way that JavaScript kind of went through the same thing, where every library assumed it was in the global scope, and then slowly moved towards things like CommonJS now that we have NPM. I think if CSS modules really takes off, I'm hoping we'll see a similar transition where you have CSS frameworks that introduce classes that you never actually use in your app. You just compose from their classes and build up your own language on top of them, for example. But yeah.
How about documentation and customization of each of the component style sheets?
Sorry, I'm not sure I understand that question.
I mean, if I use a third-party CSS module to my component, how do you suggest this? As an author of a third-party module, how do we document the usage and how to customize it?
Yeah, so I'm not sure if I understand the question, but basically it's not that different to how you might document a JavaScript project, for example, where you'll need to explain what things you can import from that library. Basically, what's the public API of this thing? And for a CSS module, in the way that I was just talking about, where you might have a framework of things that you compose your classes from, you might document and say, say there's a grid system, you can say you can compose your class from these grid classes, and that's kind of how you document the link between what are the building blocks that you provide in your CSS module or your package. Yeah.
Okay, so let's say I don't want to use jQuery UI's 2800 line of JavaScript date picker, and I want to use, say, something that you built that's a component that's up there, but I have a gigantic already existing CSS JavaScript setup. How quickly can I get that running from npm install blank date picker to that thing working in my site?
That's a really good question, and I'm not sure that we have a good answer for that yet. Webpack is a really great tool, but in my opinion, it's not that strong when you're crossing like package boundaries. Like publishing something that depends on Webpack to npm in a way that you could install it and just use it in your app, I don't think the story is that strong there. And I think that's probably where development in the future is going to have to go to make that a better experience.